Have you ever wondered how Netflix or Amazon is able to give you such a good set of recommendations? The secret behind this could be a deep reinforcement learning based recommender system. Hi, I'm Priya Balakrishnan and I'm a lead technical consultant at Vuram. I'm going to take you through how a recommender system works. Traditional recommender systems use collaborative filtering or content based systems to go about this. Collaborative filtering analyzes past interactions between users and the database to make predictions about what a user might like. The idea is that if some people have made similar decisions and purchases in the past, like say a movie choice, then there's a high probability that they will agree on additional future selections too. Meanwhile, content-based systems use additional information to develop the same set of suggestions. The system factors a few more features like say the age, gender or occupation of the user, or the various features or descriptions of the item that he's looking at, let's say a smartphone or a smartwatch. Now, moving on to deep reinforcement learning. Deep reinforcement learning is a category of machine learning and artificial intelligence where intelligent machines can learn from their actions similar to the way humans learn from experiences. Now, inherent in this type of machine learning is an agent which is rewarded or penalized based on their actions. Actions that get them to the target outcome are rewarded or reinforced. So how does this happen? Through a series of trial and error, a machine keeps learning, making this technology ideal for dynamic environments that keep changing. Do you hear e-commerce here? Yes. Although reinforcement learning has been around for decades now, it was much more recently combined with deep learning, which yielded phenomenal results. Now, the deep portion of reinforcement learning refers to a multiple layer of artificial neural network that replicate the structure of our human brain. The deep learning requires large amount of training data and significant computing power. Over the last few years, the volume of data has exploded, while the cost for computing has drastically reduced. This has enabled the explosion of deep learning applications. Now, the biggest advantage of deep reinforcement learning is that it helps to eliminate the cold start problem or empower traditional systems like the collaborative filtering. This feature is critical for e-commerce as most customers conclude their decisions by assessing the goods visuals, such as pictures. The DLRM is a DL-based model for recommendations introduced by Facebook Research. It is designed to make use of both categorical and numerical inputs that are usually present in recommender systems training data. So what are the known challenges here? Like we did mention, huge data sets, complex data pre-processing and feature engineering those pipelines, all those neural networks. And it would need extensive, repeated experimentation, which would mean huge embedding tables and sometimes distributed training to accommodate that huge data set. So what does this translate to? This translates to some of the known shortcomings, that these systems don't generalize well and don't scale well on combinatorial decision spaces. So the next time you wonder, where did that ad come from? It's likely to be a deep reinforcement learning based recommender system working with your data. Thank you.